so it might take a little bit to get used to. This is the video for scaling robots, the practice section. Let me pull it up and then allow me to do this, which allows me to write. Okay, so let's read the summary. When we create scale copies, the scale factor is the number that every length of the original shape is multiplied by to produce a scale copy. So if you look at these two triangles, and let's just focus on the corresponding sides. Let's look at this side that measures 6 and this side that measures 9. Right, so it was 6 and it went to 9. How did that happen? Well, and you can see clearly that they tell you it was multiplied by 1.5. Now, let me get this other side here, the one that measures 4 and the one that measures 6. Let's see if that same scale factor was used. So it was 4, now it became 6, and if you multiply 4 times 1.5, you also get 6. Oh, look at that. And the last side, I won't color it, it went from 5, and now it's 7.5. So what's the scale factor? Well, 5 times 1.5 is 7.5. So the scale factor is that number that each of the sides in the original shape, which is this one over here, right? And let me write original. And let me write that this is the copy. Was used to get the sides length of the second figure. Okay, so one way is to look at the numbers, and you can sometimes see very easily what the scale factor is. Sometimes it's not as obvious. This one is not that obvious. Okay, and when it's not that obvious, we can use that little formula that I gave you in class into how to find the scale factor. All right, so if it's an enlargement, if it got bigger, let me write enlargement, which is the case here, enlargement. All right, to find a scale factor, you're going to use two corresponding sides, and in this case, let's stick to 6 and 9, right? This 6 matches the side here, which measures 9. And if you focus on these two numbers, 6 and 9, which one is the bigger number? The 9. Which one's the smaller number? The 6. And if you take that to the calculator, 9 over 6, and if you simplify, you can divide this by 3, you can divide this by 3, and you're going to get 3 over 2, which is the same thing as 1.5 or 1.5. So as you can tell, the scale factor for this that was used to create the copy of the original was 1.5. Every side in this smaller triangle was multiplied by 1.5. Okay. Let's go to the second problem here. The second problem says figure A and B are scale copies. So they're telling us it's a scale copy. Okay. If it's a scale copy, then the shape stays the same, and each of the sides here was multiplied by the same scale factor. So let's just count 1, 2, 3, 4. Let me put some numbers. 4, 1, 2, 3, 4, 5. This is a 5. That's a 2. This one over here is a 4. That's a 2. That's a 2. And this is a 5. Well, we already know that. And it's going like this, right? So remember, let me get some numbers here. So this one became a 1. That looks like a 1. This looks like a... and this looks like... well, you know what? Let me just use the size that I can actually measure. So, and this is a 1. That's a 1. Well, I was going to say that this looks like 1 1/4, 1.25. This line right here. Right? But since I can't measure exactly, I'm just going to use these two sides. So, scale factor, and in this case, you can tell it's a reduction, right? It's getting smaller. So each of these sides on the original, and this is the original, was multiplied by a scale factor to get the copy version. So we can say that the 4 became a 1, right? This 4 here, this side, corresponds to this. How does a 4 become 1? Well, it's a scale factor. So when it's a reduction, right, you take the two corresponding sides, and let's just focus on the 4 and the 1. And the scale factor, to find that, you just write it's the small, the corresponding size, the small one over the big one. So if you focus on, and I'll change colors here, on these two corresponding sides, the 4 and 1, the small number is 1, the big number is 4, so the scale factor is a fourth. So in the copy version, the new side is 1/4 the size of the original. So if I know that, now that I know what the scale factor is, I can take each of these sides. So I can take the 5 and multiply it by 1/4, and you're going to get 1.25. So this side that I didn't want to tell you before, this side right here, which measures 5, right? This one, it is now 1.25. The size that measures 2, so we're going to take 2 times 1/4. And now we can clearly say that it's a half. So this size that measures 2, right here, this measures a half or 0.5, however you want to call it. Okay, that's how you get that. Number 3, there are 7 triangles. Great. Select all the triangles that are scale copies of T. Okay, so let's eliminate a few first of all, because I don't like the fact that we have so many. So look at the original. It looks like a right angle triangle, right? Look, it looks. We can't really say that it's a right angle triangle, but this line over here, right, it looks pretty straight. So any of the copies that we make, whether it's small or big, that line should look like it's straight, and everything else should proportionally have grown. So, but if you look at this one already, this line does not really match shape-wise. It's not this triangle. It's not the same shape as the blue one. So this I'm gonna not even look at. Look at F. Remember, if it's a scale copy, the shape has to be maintained. So F can be gone. And the other ones look like potentials. So let's see which ones are scale copies. So if you look at B, it went, so this is the original. If you look at B, this is 4, 5, and 3, and if you look at this one right here, it's still a 4, 5, and 3. Are they scale copies? Yes. How does the 4 become a 1? Well, times 1. How did the 5 become a 5? Times 1. How did the 3 become a 3? Times 1. Right? If you want to use a proportion, pick two sides. Let's pick two sides. Let's pick this side here and this side here. So 4/3. Right? The ratio of two sides on the first triangle should be the same as the ratio of the corresponding sides on the other triangle. 4/3. If you want to do the butterfly, 4 times 3, 4 times 3, 12 equals 12. And notice that the ratios are equal to each other. 4/3, 4/3 equals 4/3. So this one, so definitely B. Right? Let me compare it to C. So here's the original. Right? This is the T one. This is 4, 5, and a 3. Now look at C. C looks like this is a 5, this is a 4, and this is a 6.4. Well, from 3 to 4, it's times something that is greater than 1 because it got bigger, right? The 3 became a 4, so it's definitely 1 point something, right? For 5, from 4, it was times something to become 5, and then the 5 times something to become 6.4. Let's see if the scale factors, let's see if it's, if they're scale copies, if the second one is a scale copy of the first one. So, sorry, this was a 3, this was a 4. So let's pick two sides. Let me pick this guy, 4 and this 3. And over here, I'm going to pick the 5 and the 4. So let's set up a proportion. So 4/3 equals 5/4. Are the ratios the same? No, they're not. 4/3 is not the same thing as 5/4. And if you wanted to confirm it again, 4 times 4 is 16, and 3 times 5 is 15. So that also tells you that these two are not scaled copies. If you wanted to find the scale factor, well, it looks like if you go from here to here, it's an enlargement, right? Let's take one side here. Let's take this side here, right? And then the corresponding over here. So scale factor It's an enlargement, so if it's an enlargement, it's going to be big over small, right? So the big number is 5, the small number is 4. So that's telling us that to go from 4 to 5, we multiply that by 5 over 4. Well, if you multiply 4 times 5 over 4, this simplifies to 1, and 1 times 5 is 5. So that works for that one. So 4 to go to 5, let's times 5 over 4. What about 3 going to 4? Well, 3 going to 4 should have been also be multiplied by 5 over 4 because it's the same scale factor. Is that true? Well, 3 times 5 over 4, first of all, 3 times 5 is 15 over 4, and 15 over 4 is the same thing as 4 goes to 15. 3 times 3 over 3, 4. So is it the same? No, because you can tell already that they're not. If that was properly done and the same scale factor applied, instead of this 4 here, we should have seen 3 and 3/4. Not the case, which means this is also not. Okay. Let's look at this big one here. So again, here's our original. 4, 5, and 3. This is the enlarged version. So this is an 8, this is a 6, and this is a 10. This one I think it's pretty obvious. How did the 4 become an 8? How did the 4 become an 8? Times 2. How did the 5 become a 10? Times 2. How did this 3 become a 6? Times 2. So it's the same scale factor. Yeah? So that's one way of showing it. Another way, you could have picked two sides, and let's say 4 over 3. 4 over 3. And you could have picked 8 over 6 here, right? Simplified, you can do the cross multiplication. 4 times 6 is 24. 8 times 3 is 24. So notice that's when you cross multiply, they're equal. You can simplify, so you have 4 over 3. And if you simplify 8 over 6, it's also 4 over 3. Notice that their ratios are the same. You could have done what we did in class today, find the scale factor. We already know it's 2, but I'm going to do it anyway. So this is an enlargement. Right, so let me pick two corresponding sides. So let me pick the 4. Let me change colors. Let me pick the 4 and the 8. Right, so when it's an enlargement, we're going to use it's big over small. So using the corresponding sides 4 and 8, it's going to be 8 over 4. And if you divide 8 divided by 4, you get 2. So the scale factor is 2, which we already knew. So this one, E, definitely a scale copy. There's one here. Okay, here we go. Let's see if that one's a scale copy. So again, here's the original. This was 4, this is 3, and this is 5. And it grew to 4.5, 6, 7.5. So, easiest way, I guess, is set up a proportion. So I'm going to take these two sides here in this triangle. So that ratio, 4 over 3, is it equal to these, the 6 over 4.5, right? 6 over 4.5. Okay, you can cross multiply. 4 times 4.5, if you put that in your calculator, you're going to get 18. And if you multiply 3 times 6, you also get 18. So that's a definite check. That means that they are scale copy. This is a scale copy of that one. Now, what if you wanted to find the scale factor itself? Well, if you want to find the scale factor itself, right? How did 4 become 6, right? 4 times what is 6? 5 times what is 7.5? And 3 times what is 4.5? What are we multiplying by? If I asked you for a scale factor, well, pick a side and let's just stick to 4 and 6. So let's stick to this 4 and 6. Is it a reduction or enlargement? It's an enlargement. Right? So let's use the corresponding 4 and 6. So it's going to be big over small. So using those two numbers, 4 and 6, it's going to be 6 over 4, which give us 3 over 2, or 1.5. So if you take 4 and then take a moment, multiply every side in the original triangle by 1.5. Is 4 times 1.5 6? Yes. Is 3 times 1.5 4.5? Yes. Is 5 times 1.5 7.5? Yes. So scale factor is 1.5. Okay, not bad. Oh no, I just did this. Okay, we literally just did this for every single problem, so I'm not going to write the scale factor. Um, so actually, I will. Sorry, I'll write it. So if you look at the first one, right, triangle A, is that a scale factor? No, so I'll just put an X. That's not, first of all, is it a scale copy? No, it's not, so this is gone. B, was it a scaled copy? Yes. It's the same shape. Was each number multiplied by the same scale factor? They each was multiplied by 1. 4 times 1 is 4, 3 times 3 is 1, 3 times 1 is 3, 5 times 1 is 3. So this one is good, right? This one, we said that it was not, so I'll put an X. D, we just did right now, and the scale factor was 1.5. Okay. E, scale factor was 2. And F, obviously, it was not a scaled copy, so we didn't have to worry about that one. Select two triangles that can be represented by the equivalent ratios 4 over 8 equals 5 over 10 equals 3 over 2. Okay, so I see what they mean. So they want us to use, right, to set up a proportion. So remember what I said before. One way of checking. So this is a 4, this is a 5, this is a 3. And this is a 8. And this is a 6. And this is a 10. What is it, slide 5? So if you set up a proportion, right, you can set that this side over here, right, the corresponding sides you can use, look at that, 4 over 8, you can use 5 over 10, and you can use 3 over 6, right? So that's literally what they meant. I don't want to make the video too long because it's your first one, but here, this one, a little pain in the butt, but nevertheless, they're asking us to use the numbers 0 through 9 without repetition to make rectangles that are scale copies. So for example, let's pretend I made this a 3, and let's pretend I made this a 5, right? And I wanted to increase. Well, let me multiply the 3 by 4 and the 5 by 4. I'll make it bigger. I'm going to use a scale factor of 4. So if I multiply 3 times 4, this side is now 12. Okay. And if I multiply the top by 4, that side is now 20. That's perfectly okay. These two would have been, the second one would have been a scaled copy of the original. Completely okay, but I broke the rules. It says I can't use the numbers without repeating myself. So what's my problem here? My problem over here is that I use a 3 once, I use the 5 once, but look at this. The number 2 was used 2 times. I am not allowed to do this. Okay, so you have to play around a little bit. Okay, let me try another one. I'm going to try 2. Let's pretend this is 2, so I use a 2. Let's pretend this is 4, so I use a 4. Let me increase it by scale factor of, no, not that one, not that one. Let me try 9. So let's say I made this, right? I multiplied that side by 9, and I multiplied this, the height, by 9. So 2 times 9 is 18, so this would now be 18. This height here would be 18. And on top, 4 times 9 is 36. Oh, look at that. Does this work? Yeah, because I used the number 2 once, the number 4 once, the number 1, 8 once, the 8, the 3, and the 6. No number shows up twice. Okay. Right, so that wasn't that bad. That would be worse. 7. Okay. What is a scale factor that takes polygon A to polygon B? So it's a scale. They are scaled copies. Okay, so we don't have to worry about that. So it's taking what takes. How did this happen? How did 2.5 become 5? How did 1.5 become this side here, right? And how did this is 2.5, so what is the new one? Well, because they are they're telling us that this is a scale copy of each other, I am going to just pick on this. I don't have this side. I don't know what that is. I don't know what that is. It doesn't matter. But because I know they're scale copies of each other, I can just use the 2.5 here and the corresponding side on the new shape, which is this one. So I can use these two to find the scale factor. It's an enlargement, right? It got bigger. Enlargement. So scale factor when it's enlargement, right? You're going to use those two corresponding sides, and you're going to use the big number over the small number. And that's going to give you, well, the two numbers we're using is 2.5 and 5, so it's 5 over 2.5. So scale factor 5 over 2.5 is just 2. So what's happening here? Every side is going to be multiplied by 2. Now the two sides that I didn't know before, now I do know. What's 1.5 times 2? Well, that means this guy's 3. And this 2.5, if I multiply by 2, means that this guy over here is 5. 8 is, okay, same type of problem as the last one. Okay. So polygon B is a scale copy of polygon A. Enter the missing lengths in polygon B, which I did in the previous problem. We found out that the scale factor was times 2. So 1.5 times 2, this was 3. 2.5 times 2 makes this 5. Okay. And that little angle over here, well, when you create a scale copy of the original, two things stays the same, the shape and the angles. So they're telling us this measures 82 degrees, and this one, the angle also doesn't change, which means that's also 82 degrees. Okay. Oh no, where am I? Sorry. So let me go to, sorry. And this one is just a little, hang on, 9. Oh, okay. Taylor's Tyen says a K, this one, is a scale copy of G. So it went from this to this, right? And they're saying it's obviously a reduction. It looks like it got smaller. Is he correct? Well, look at this. Went from 4 and now it's 2. So we know the scale factor, right? So let's find the scale factor. So it's a reduction, so the scale factor. And because it's reduction, it's small over big. And let's use the two corresponding sides. The small number is 2, the large number is 4. 2 over 4 is the same thing as a half, or 0.5, however you want to write it. So the scale factor, which means every side should have been reduced by half. Does it look like that happened to every side? Well, the 4 becoming a 2, that's okay. It was cutting half. But look at the length here. And look at this length here. Does this, now change colors, does this side, which was whatever, does that side look like when it went to become the scale copy had a reduction of 2? Does it? It doesn't. It should have been half the size. So is he correct? No. So don't be fooled by this. That one definitely had a reduction, but all the other sides didn't follow through. Okay, so definitely not a scale copy. Oh my god. 10. 10. Okay. This one is just a spiral, a little practice. So how do you multiply 1/4 times 32? Well, I'll do it over here. So if you 1/4 times 32, if you wanted to, you can put the 32 over 1. How do we multiply fractions? You multiply across. 1 times 32 is 32. 4 times 1 is 4. But we can simplify that. 32 divided by 4 is simply 8. That's one way of doing it. Okay. 1/4 times 5.6. The same thing. You multiply across, 5.6. 4 times 1 is 4 times 1 is 4, and 5.6 divided by 4 is just simply 1.4. 7.2 looks like 72, right? Times 1.9. Well, multiply across if you want to. 7.2 times 1 is 7.2. 1 times 9 is 9. And 7.2 divided by 9 is 0.8. 2 divided by a fourth. Now this one, 2 divided by a fourth. Division, right, is the same thing as multiplying by the reciprocal. So you can say 2, change the division to multiplication. The reciprocal of 1/4 is 4, which equals to 8. Think about a pie, right? 2 pies. Here are my 2 pies. And you want to cut them into 1/4 slices. How many of them do you have? You have 1, 2. This is 1/4. This is 1/4. This is 1/4. This is 1/4. 1/4, 1/4, 1/4, 1/4. So if you took 2 pizza pies and you cut them in 1/4, how many slices would you have? 8. This one is 8. And that's exactly what this question is asking you to do. And we have one more. Here are your results. I'm going to leave that to you. And that's that. So I'm going to upload this to Google Classroom.